the y-axis. The y-axis is the line of symmetry. The graph of cosine is the y-axis is the line of symmetry. Okay, so I'm going to draw it again, I think. So the graph of cosine, y-axis is the line of symmetry. Because y-axis is the line of symmetry, it's an even function. But the graph of sine 0 is 0. So sine 0 is symmetric with the origin. Therefore, it's an odd function. So sine function is symmetric with the origin. Cosine function is symmetric with y-axis. Okay, it's really easy. The cosine function is an even function. Sine function is an odd function. Cosine function is an even function because it's symmetric to y-axis. Sine function is an odd function because it's symmetric to the origin. Okay, so that is for this one, and there are already questions on sine and cosine functions. So you see a question, an angle. Suppose you're given cosine of negative 80 degrees, write it. Yeah, then you have to know it is cosine of negative 80 degrees is cosine of 80. Okay, and then we are quickly going to difference of squares. Let's see it here. We're not going to prove it because we don't have time, but we're going to use it to solve problems. And all these, you don't have time to actually go through the proof, but you should be able to use it to solve problems. You are allowed to use your identities. It is the identities. I put a copy in module 2, which is unit 2 folder. Okay, so let's go to the practice test. Practice test 2. So let's go to practice test 2 and see questions on, we're not going to be talking about, and by the way, they will ask you to define. You already know the formula for a sine function. So y is equal to amplitude into sine b into, even if b is inside, but suppose it is like this. Let me just put it inside. Suppose it is 6x minus 9, and then you look to 7 here. Suppose you are told to extend this. You use transformation. You just compare it with the quadratic function, your transformation in vertex form. So just say a into x minus h squared plus k. So you are just going to be using transformation in vertex form of quadratic equation. Where your 7 here is the amplitude. Okay, and this quantity here, I don't have c, I don't have a d, but this is d. So let's call this one b. There's no b. If I am told to explain this, I can find the period. We already know that the period of sine is 2 pi. So I will say 0 is less than the quantity in the middle, 6x minus 9 is less than 2 pi, and I solve for x. When I finish solving for x, I will see the phase shift. So this is the phase shift, horizontal shift in your quadratic. So let's equation. So let's go ahead and find the phase shift. Plus 9 on both sides. And so this is negative 9. Okay, this is plus. So plus 9 is less than 6x is less than 2 pi plus 9. But I'm solving for x. I'm solving the compound inequality for x. Divide both sides by, divide all the 3 sides by 6. So I will find the phase shift. Where does this start? Where did it stop? So right hand here I have 3 over 2 is less than x, and x is less than, and right here I have pi over 3, that's 2 pi over 6, pi over 3, plus 3 over 2. Therefore, the graph started from 3 over 2 and ends at pi plus 3 over 2. So anyway, the important thing is that you can now explain this. So you know that the amplitude, so you can eliminate. From now on, you can eliminate. Amplitude is 7, the period. And how do you find the period? What is a period? So we know that, first of all, that the phase shift is 3 over 2. And then you can go back and put that in and solve for the B. Okay, so remember that period is 2 pi over B. And then you can solve for that. But if you can find the other ones, you can discover the remaining. Okay, so the next thing now we're going to do is find the period. Okay, you can do this. If you can find that of sine and cosine, you can do the cosecant and secant. Remember, if you're told to graph sine, cosecant, then you graph sine we did that last class. Then from sine, all the maximums of sine are the minimums of cosine. Same thing for secant. If you're told to graph secant, then you graph cosine. All the maximums of cosine are minimums of secant, and so on. Remember, you have your calculator, by the way. All right, so we found out that the period of tangent, period of tangents, let's go back here. This is 1, 0, and this is 0, 1. Period of tangent, so we want to negative 1, 0, and this is 0, negative 1. And we know that sine 0, we're talking about tangent though. So tangent of 0 is sine over cosine, okay, which is 0. Tan 0 is 0. Tan 0 is equal to 0. Tangent of 90 degrees is undefined. Why? Because sine over 0 is, you say it's infinity. And then you go back to 180. We want to see what is so let's go to 180. What is sine of, tangent of 180? Sine over cosine, which is 0 again. Okay, so we already met, so we have one complete cycle. So one complete cycle of tangent is from here to here. So within 360 degrees, there are 2 cycles of tangent. Within 360 degrees, there are 2 cycles of tangent. In other words, you can start from negative pi over 2 to pi over 2 when you're graphing. Don't forget that you have a calculator. That's the most important thing. But there are things you can use to do. We talked about reference angle. There's no reference. We're not going to talk about reference angles today. So if you are told to find this angle, give the degree measure of theta if it exists. Do not use a calculator. So anytime I'm told to find if an angle is cosec inverse, if an angle is cosec inverse of this, I will first of all find the sine. Remember, you can find the sine, and then, and by the way, what is this angle? So we can check it out and find what the angle is. But I just want to make sure you know how to use it in the calculator. If I'm looking for sine, I'm going to clear this and also take this out. Let's start from 30. So let's from 30. Suppose I'm told to find, I know that sine 30 is 1/2. But suppose I'm told to find cosec 30. Or what is the angle? See, what is the angle whose, this is what it said. What is the angle whose cosecant is this? What is the angle? Okay, so you should be able to use your calculator or do it without calculator. So what you're going to do is the sine of that angle, you want to rewrite it this way, and I'll flip it over. Is 3/2√3. And then put it in my calculator. So what is that angle? So let me get my calculator and find that. Of course, we know that sine cannot be more than 1. If that angle showed up to be more than 1, the angle does not exist. Sine and cosine has one cycle, and around the circle, there is nowhere where sine is more than 1. So if the angle is more than 1, you reject it. The sine does not exist. So let's figure that out. By the way, so now I want to look at the denominator before I continue. Because if the angle is more than 1, so what I'm trying to say is that if I multiply this out and it is more than 1, then I know the angle does not exist. So I have to multiply square root of 3. What did I get the answer? That's 2. Okay, 2. That's what I want. Okay, multiply the square root of 3. Square root of 3. Come on. Square root of 3. Second bit. All right, square root of 3. Okay. Okay, so this angle is greater than 3, so I can continue. So what is that angle? What is the angle? And I have stored this in my X. All right, what is the sine inverse? What is the sine inverse of that angle? I can get it in degrees so that I know what I'm getting. So what is the sine inverse of 3 divided by x? I stored it in my x variable. So x plus parentheses. Before I can just go and change my mode to degree, because I want this angle in degree. I can change it to radian later on. So I have second quit. I evaluate my answer. So that angle is 60 degrees. But there are so many other ways you can. And this, since sine is 60 degrees, I have found the angle is, give the degree measure. So the degree measure is 60 degrees. Okay, I found the angle in degrees. It exists. But before I do that, I want to test that that angle, the ratio is not more than 1. The ratio cannot be more than 1, because the ratio of cosecant can be more than 1, but the ratio of sine cannot be more than 1. Cannot be more than 1. So I tested it. I know that the denominator is greater than the numerator. Then I continued. Okay, the same. There are things. Then if you're told to, you can use your calculator. You're told to find the exact value. I talked about this the other day, but let me say it again. Suppose I'm told to find the exact value of an angle in radian, and by all means, human beings forget. And I have forgotten what that angle is, so I can multiply it out using the multiplier for conversion to radian. Okay, so pi goes with pi, 6 goes into this, and I have 3 and that's 30. 7 times 3 is 21. So the angle is 210. Give the exact real number value of the following expression without using a calculator. So all the round and round you're going, you want to know what the exact angle is. 210 degrees, and 210 is in the third quadrant. And since it's cosine, it has to be, your answer is going to be negative already, because in the third quadrant, cosine is negative. And by the way, what is the reference angle for 210? It is 30. So that reference angle is 30. And so reference angle, it is, remember I'm talking about cosine. So I can actually draw my 30, 60, 90. This is 60, this is 30. No problem if you can remember, but if not, go ahead and put it in your calculator. What is the cosine of 30 adjacent to the hypotenuse? So negative, don't forget, negative adjacent over hypotenuse, root 3 over 2. Give the exact real number value. The exact means your answer cannot be in decimal, and somebody is testing to see if you know that all students take calculus. Also, somebody is trying to see if you know your reference angles. The reference angle property will always be here until we finish this class. It's going to be here in polar coordinates. It's going to be here in complex numbers, so you cannot miss it. That's why we did unit circle. If you did unit circle, you must know how to use complex numbers. Any questions so far? So we evaluated an angle. And by the way, then if you're told to find the cosine inverse of cosine, I just want you to know that it's just going to be, what is the cosine inverse of cosine? It's just going to be the same angle. But somebody is testing to see if you actually know that this angle is in the third quadrant. Secondly, can you find the reference angle in the third quadrant? Evaluating it will not be a problem because you can use your calculator. Nobody's going to stand behind you. But there are things that if you don't know your unit circle, somebody's going to know anyway. Okay, so some of you will say, why is it that there are equations here? I want us to make sure we do whatever we can do, because really, the remaining 2 weeks will not be enough